For our entire history, we've looked up at the night sky and essentially thought, we won the cosmic lottery. We've always just assumed that our lush blue and green home is the absolute pinnacle of habitability in the universe. But what if we've been looking at this all wrong? What if we were actually living in a cosmic fixer-upper? So is Earth really the best planet for life? It sounds almost like a trick question, right? But scientists are actually undergoing a massive paradigm shift right now. It turns out there might be bizarre, completely alien worlds out there that are significantly better suited for rich, complex biodiversity than Earth is. We're talking about super-habitable worlds.
And look, we aren't just guessing anymore. Think about this. Just 30 years ago, we didn't have a single shred of scientific proof that a planet existed outside our solar system. Not one. Today, thanks to massive leaps in telescope tech, we have confirmed over 5,300 exoplanets. At first, we were mostly just spotting these massive gas giants, think Jupiters and Saturns, mostly because they're huge and easy to spot. But now, our technology has sharpened, and we're hunting down smaller, rocky candidates.
Here's our roadmap for today. First, we'll rethink the Goldilocks zone. Second, we'll visit the Gliese of 667 system. Third, we'll look at older, warmer super-Earths. Fourth, we'll explore the Terminator zone. And finally, we'll take a look at our crowded cosmic neighborhood.
Okay, Section 1, Rethinking the Goldilocks Zone. Let's establish what actually makes a planet not just livable but actively better than Earth.
The absolute baseline requirement is the Goldilocks zone. You've probably heard of it. It's that perfect orbital distance where water doesn't just boil off into vapor and it doesn't freeze into solid ice. But the absolutely crucial thing to understand here is that this zone is not a fixed distance in space. It shifts dramatically depending on the host star. If the star is a massive, incredibly hot scorcher, that zone gets pushed way out. But if the star is a faint, cool dwarf, the habitable zone gets pulled incredibly close, almost right up against it.
Now, when scientists hunt for worlds better than ours, they actually aren't looking for Earth winds. They're looking for super-Earths. These are planets with a mass up to 1.5 times ours, and maybe about 10% larger in size. So why is bigger better? Well, that extra mass helps the planet hold on to a much thicker atmosphere. A thicker atmosphere traps heat more efficiently. And if global temperatures were just about 5 degrees Celsius higher than Earth's, you could support a significantly richer, more diverse web of life.
Section 2. The Gliese 667 system, a surprisingly crowded neighborhood. Our first major destination is located just 23 light-years away from us in the constellation of Scorpius. In galactic terms, that is practically right next door.
What is truly fascinating here is the sheer complexity of this system. We're looking at 3 stars. Stars A and B are these larger orange-red dwarfs. But honestly, the really prime real estate orbits the tiny, faint third star, Gliese 667c. It's only got about a third of the mass and radius of our Sun and puts out a measly 1.4% of our Sun's visual light.
Yet despite its small size and a comparatively cold surface temperature of just 3,775 Kelvin, which is way lower than our Sun's nearly 5,800 Kelvin, this specific star hosts a surprisingly rich planetary system. At first, scientists thought there were only 3 planets here. But after diving deeper into the data, they realized there might be 6 or even 7 planets, with multiple super-Earths tucked safely inside its habitable zone. Specifically, we're talking about Gliese 667c, C, and CF.
Let's focus on the prime candidate, Gliese 667c. Because the host star is so faint and cool, to stay warm, planets have to huddle up incredibly close. For some perspective, Earth sits at 1 astronomical unit from the Sun. Gliese 667c, it orbits at just 0.12 AU. It is 8 times closer to its star than we are to ours. It's whipping around that star so fast that an entire year goes by in just 28 Earth days.
Now here's the catch. When you get that close to a star, you experience something called tidal locking. The gravitational pull literally locks the planet in place, so it takes the exact same amount of time to rotate on its axis as it does to orbit the star. The result? One side of the planet faces eternal, permanent day, while the other side is frozen in endless, permanent night. Without a really thick, Earth-like atmosphere to distribute that heat around the globe, the climate extremes between those 2 sides would be completely devastating.
And we can't forget the physical toll. Because Gliese 667c has 3.8 times the mass of Earth, its surface gravity is about 60% stronger. If you weigh 75 kilograms, about 165 pounds on Earth, stepping onto this planet would instantly make you weigh a crushing 120 kilograms, or 265 pounds. Imagine trying to just take your morning jog with an extra 100 pounds strapped to your back. So living here would be absolutely wild. Your daylight would be this faint, reddish hue. At night, those two companion stars, A and B, would be visible, shining as brightly as full moons. But it gets hostile. Red dwarfs are notorious for intense radiation flares, sometimes up to 1,000 times stronger than what our sun spits out. Plus, massive star spots can reduce the star's energy output by 40% for months, plunging the planet into a deep freeze. And if it has a Venus-like atmosphere, the surface pressure would feel like you're several kilometers deep in Earth's oceans. Yet, despite all of this, it has an Earth similarity index of 0.85, making it a holy grail of exoplanets. Because life is incredibly adaptable.
Moving on to Section 3, older, warmer, and better. Because let's be real, if dodging brutal solar flares while dragging around 100 extra pounds of body weight sounds a bit too tough, we need to explore planetary candidates that are arguably much more stable. Enter KOI 5715.01. This one is quite a trek, 3,000 light-years away, but it checks almost every single box for super-habitability. The system is estimated to be 5.5 billion years old. That is a full billion years older than our solar system. Why does that matter? Because it took complex life on Earth about 3.5 billion years to appear. A planet with a billion-year head start has had vastly more time for complex, rich biodiversity to evolve. It's almost double the size of Earth. And while current data suggests that might actually be a bit colder than Earth right now, a strong greenhouse effect could easily boost those temperatures up by that required 5 degrees Celsius. Or take Kepler's 69c, located 2,700 light-years away. This system is ancient, around 7 billion years old, and it has almost 4 times the mass of Earth. A rocky planet of that immense scale could feature a single, colossal supercontinent with massive deserts right in the center, but surrounded by endless, lush, habitable coastlines. There's also Kepler 1126b, located about 2,000 light-years away and a staggering 7.5 billion years old, orbiting a yellow dwarf much like our own, but closer in. Section 4. The Terminator Zone. Life on the edge of light and dark. We've gone thousands of light-years out, so let's reel it back closer to home for a truly bizarre but highly promising habitat. Meet Speculoos 2c. It's only 106 light-years away. It's a rocky super-Earth, about 40% larger than our planet. Its host red dwarf is tiny, only 15% the size of our Sun. Because the star is so incredibly small and faint, Speculoos 2c has to orbit really tightly to stay in that habitable zone. In fact, it completes a full orbit and a full rotation in a mere 8.5 days. Now, because of that rapid 8.5-day orbit, it is absolutely tidally locked. One side is boiling in endless daylight, the other is freezing in endless night. But life here wouldn't be everywhere. It would likely cling to what astrobiologists call the Terminator Zone. This is a perpetual twilight ring, a thin strip of real estate bordering the light and dark sides, where the temperatures perfectly balance out between boiling and freezing. Just imagine it, an entire planetary ecosystem confined to a permanent, never-ending sunset. And finally, Section 5, a crowded neighborhood. We have covered a lot of ground today, but what is the absolute crucial point you should be taking away from this galactic tour? It's this: the sheer statistical probability of finding these systems is staggering. Densely packed planetary systems around faint red M-dwarf stars, like Gliese 667c and Speculoos 2c, they are not rare anomalies. In fact, these stars make up over 70% of our entire cosmic neighborhood. And honestly, that changes everything about our hunt for life. We don't have to search 10 different stars hoping to find one lonely planet anymore. Knowing that a single, extremely common red dwarf can host multiple, potentially habitable super-Earths means the universe isn't just sparsely populated with dead rock. It is quite literally teeming with cosmic real estate. It means there are millions of potential worlds out there that, thanks to being older, slightly warmer, and more massive, might actually foster biodiversity far beyond what we have here at home. So I'll leave you with this. If our little blue dot isn't actually the peak of habitability, what incredibly evolved forms of life are right now looking up from the Terminator Zone of a super-Earth, wondering if anyone else is out there?